Charles, Germany, and today we're going to take a look at Linux's POSIX permission system. Came from Unix. We're in Ubuntu 7 or Feisty Fawn, and you can manage things graphically. Leave that terminal. We'll take a look at a couple other graphical tools. So for users and groups, if I wanted to. Cursor's blinking. Yeah. To go ahead and read the group file and the password file. But if I wanted to add a user, I could add the user here, modify privileges. If I wanted to manage groups, I could manage groups or add a group. I could add members of the group. So it kind of gives you similar functionality to what you might find on 2008, 2003 server or say Vista or XP Pro. And there are several other graphical tools that are very convenient for administering services. Just like you have that graphical capability in Windows, you also have it in Linux. To get a better grasp, here's like remote desktop. If I were going to use remote desktop, I can choose to grant permission to connect. And basically, if anybody who has a VNC client, if I change the password here to password, now you have permission to connect to me via remote desktop. So you have all these wonderful graphical tools, but again, just to try to illustrate things, we're going to use some of the command line tools today. And we'll take a look at the permission system and just adding a few users and groups and things. So I'll try to blow this up nice and big so everybody can see what I'm typing. I have no idea what the resolution will be by the time I compress this. Small enough to fit on YouTube, but we'll try. So first off the bat, let's use the, well, let's see where we are. I'm going to go over here and over here. Print working directory. Okay, now there's the groups command that'll show us, the groups that we're in. And you can supplement that, you can supply a username. So here are all the groups I'm in. Now every user who gets created or added in Linux is added to a group that matches their name, and by default they are the only member of that group, with the exception of I'm also admin, so I have root privileges, or I have sudo root privileges. Now if I wanted to specify another user, I could groups root, and then depending on the permissions you may have to sudo, but let's go ahead and create a user. Well, even before we do that, maybe we should look at the configuration files, and we'll look at them before and after. Most of your configuration files in Linux are in a folder called etc. I like to affectionately call it etc, but etc, etc, whatever. These files, all of these configuration files may usually be found in the etc folder. There's a few you'll find in like boot /grub conf, your grub configuration file, but most of them are in etc. In this case, I'm looking at the group file, and these are all of the groups that we have. So here's Austin Powers, kind of like in some of our other examples. We have a Dr. Evil. Let me pipe that to less so we can pause it. We'll go over and look for Dr. Evil. And we have a lot of daemon groups here, the different daemons use. And it's like there's no Dr. Evil here. So let's do that. Let's add Dr. Evil. So we're going to use a command called user add Dr. Evil. And oops, we need to use sudo. Keep thinking I'm in Fedora and I'm in Feisty Fawn. Okay, so we used user add to add Dr. Evil. Now we need to give a password to Dr. Evil, and that's the password command. And we won't give Dr. Evil a complex password. That way Austin Powers will have a easy time brute forcing his password, or possibly even a dictionary attack. Now what we want to do is look at our group file, and notice now there's a group for Austin Powers and Dr. Evil, all of our users, and also we'll look at the password file. So I'm going to You can see, it's an encrypted or hashed value, Austin Powers or Dr. Evil. By the way, one of the things you can do in Linux, if you ever lock yourself out, forget your password, or need to do a password recovery, if you will go in and delete this section where the hashed password value is stored, now you'll need to gain temporary root privileges, so like boot off of a live CD, and then you have to be able to mount the ext2 or ext3 or riser partition. But once you do that, if you can change this and save it, you can reboot the system and then log in as that user, and you won't have to type a password at all. And then you can use the password command to reset the password. Similar to kind of what you can do with Locksmith and Windows. You can use Locksmith, you can boot up and you can, change the administrator password in XP or 2003 server if someone has forgotten their password or they're locked out of their machine. So anyway, we've made a couple of these users here. Now we're going to make a couple of groups, so we're going to use a command called group add. And in the group add command, we're going to make, let's see, we'll make one group called good guys. And once again, let me sudo. And we're going to make one group called bad guys. Okay. Now we want to use a command called user mod, and we want to set the primary group and we'll append user mod, and we want to add, in this case, let's do use the G option here, and once again I need to sudo that. Okay. Now let's make, we're gonna group, use the command groups, and again we just want to make sure that, so he's a member of Dr. Evil and now he's a member of Bad Guys. That's his primary group. So we're also going to want to do user mod, and we will give Austin Powers group membership. And what do we call it? Good guys. We'll put him in good guys. Austin Powers. Okay, let me do Austin Powers. Yeah. Okay, now we'll use groups. And Austin Powers is now in good guys. So we'll look at our file system. And let's break down the POSIX permission system. So I'll do a long listing here. And you'll notice the way things appear. Let me move the cursor. Over here is what follows. In this case, we have a soft link prefixed with an L. These are directories prefixed with a D. In this case, files or objects would have an appropriate prefix. The way that Linux divides things up, there's three categories that you have. These first three here, we'll take a look at this directory, is these permissions belong to the owner. Now, these next three here, this belongs to the group, and these last three here that I'm highlighting, that belongs to other. Now, other's kind of like everyone that you're used to in Microsoft Windows. So it's just kind of, anybody who's not in the group and they're not the user, well, then they're automatically in the other category. Now here we have read, write, execute, R for read, W for write, X for execute. So you have permissions that are listed this way. Now each of these has a numerical value. So read has a value of 4, write has a value of 2, and execute has a value of 1. So for all permissions, they accumulate, or they're cumulative, so it would be read 4 plus write 2 plus x1, so 7. That would be all permissions here. Now here, if we were going to chmod this, the command chmod is what you use to modify permissions. This would be a 4, it's read, and this would be a 1, it's execute. So 4 plus the 1 would be 5. So you have 7 here, the combination of all of these. 4 plus 1 here, that's 5, so 7, 5. And the same thing here, read is 4, X is 1, add them together, that's 5. So this particular directory here if we were gonna, if we were gonna create these permissions or needed to create these permissions, we would have to use the command chmod, and we would say 7 for all of them, 5, 5. So that's kind of the way that it works. Um, let's try that. We'll make a directory. Uh, we'll call it top secret. And again, I need to sudo. Gotta get used to being in Ubuntu again. Okay, and there's our top secret. And let me... I don't like... I don't like the way I spelled that, so... Boy, nothing but typos today. Let's go ahead and call it... Yeah. Okay. Alright, now this will be called top secret. Let's look at the default permissions, and this comes from the UMask value. Matter of fact, we'll look at this is our default UMask value. This means no special permissions, which is a fourth category we're going to talk about in a minute. And, in this case, UMask is sort of the flip side or the inverse of permissions. It defines what permissions are removed by default when you make something. So I made this. I haven't used chmod to assign the permissions. Here's my UMask. So no special permissions. And again, notice nothing funny here. Otherwise, you'd see S and T if there were special permissions there. So none of that was removed. In this case, none of the root permissions were removed. So if none are removed, that means 7, right? That's all permission. And by default, see, that's what we got. The root category here has read 4, write 2, and execute 1, so that's 7. Now by default in the UMask, 2 is removed. Now remember, 2 is write. Remember, read is 4, write is 2, and execute is 1. So write is going to be removed for both the group and for other. And if you look here at top secret, again, here in the group category, there's only read and execute, no write. And there's only read and execute in other, no write. So that is corresponding to or according to that UMask value. Now, add a little bit of a little bit of space here. Now let's say that we wanted to change the permission and give, in this case, root and root. I'll tell you what. Let's first change the group membership of top secret. So the owner is root. Use the command chr group or chgrp. And let me sudo that. And let's change who. Good guys. Alright, so now I'm going to do a long listing. And in this long listing, we're going to take a look at top secret. You'll notice now it's no longer root, but we've changed group membership to good guys. So good guys owns top secret and not bad guys. Now root is the owner here. If I wanted to, I could change the owner with the chown command. And again, if I wanted to change the owner to, let's say Dr. Evil comes in and he takes over. And I need to sudo that, and remember Linux is case sensitive. So a lowercase or uppercase where it shouldn't be, and it won't recognize those commands. Alright, now if I go through, look, if you notice Dr. Evil is the owner of the directory top secret, and good guys is the group. Now we can't have that, so let's change ownership back. And in this case, we'll change ownership to, I think I'll take ownership of it, so and let me sudo that once again. Okay. So let's take a look at that, and now we can see that C Germany is the owner and good guys is the group here for top secret. Now let's try the chmod command. Let's say we want to give good guys all the permission. Now good guys only have read and write. Excuse me, read and execute. Let's say we want to give them read and write. So we're going to do that here. I would say chmod 777 and have my number pad turned off, 777, and that's me, and now I want to say 7 here for the group, and I'll continue 5 for other in this case. Okay, now let's take a look at our permissions. Again, we'll do a long listing, LSL. Now if you look, now in this case the owner, which is me, C Germany, has all permission. The group, which is good guys, has all permission. Another still has only read and execute. They don't have write privileges and top secret. Now in Linux, if you don't have execute privileges, you're not even allowed to traverse or change into a directory. So be aware of that. If you decide to remove the execute privilege, then that particular user or group will no longer be able to change directory into that directory. Sometimes that's what you want, but not always. We're going to go into top secret, and there are no files in here yet. We haven't created any. We're going to use a command called touch, and we'll make some files. That'll be our file called deathray. And let's do world domination and master plans, and we're going to do an ls-l, and now you can see in this case we have 3 files: deathray, master plans, world domination. And let's look at the UMask here. In this case 002. So no permissions were removed. Since I created these files, I'm the owner of these files. But what we want to do is take a look at a few here. Take a look at a few more permissions. There are 3 more permissions. The substitute user ID, SWID, which gives a user temporary root privileges. The SGID, which makes any files created in a directory owned by the group of that directory. And then there's the sticky bit, which means that only the user who created the file can delete it, although other users can modify it. And we're going to set those permissions, and I want you to see what happens here. First thing I'm going to do, just because it's, I guess, the most dramatic change, we'll do a chmod, and we'll turn all the special permissions on. So I'll still leave other at 5, so they've only got read and execute. So all the special permissions 7, in this case C Germany, right here, will have all the permissions, and the group good guys will have all the permissions, and then other, the last group, will only have read and execute. Okay, and let's see what that looks like. Clear the screen there. Now notice that the X has been changed to an S, and an S, and a T. Now if it's S, that means that both execute and, in this case, in this position, the substitute user ID is granted. If it's S here, that means that both execute and the SGID permission has been granted. And if it's just a T, then that means, sure, the sticky bit has been turned on or granted, but the execute is not, excuse me, the execute is also granted, but, let's look at that. Yeah. Okay, so there's our sticky bit. Alright, now what I'm going to do, I want to go back into top secret. And I'm going to list some files here. Now notice, by default, the group was CH Germany when I created those files. I'm going to make one more file here. Let's see. And now I'm going to list the file contents. Now notice, now that I've set the SGID, in this case, now the default group is good guys. So particle beam weapons. So we've modified that or changed that. And were I to log out and log in, just like in Windows is, a different user, depending on what my group membership was, I may or may not have permission to go into this folder and to read the files there. I may or may not have permission to write to them. I may or may not have permission to change directories from one directory to another just by manipulating or controlling. There's different permissions: the execute permission for changing directory, read permission, write permission, the SUID, the SGID, and the sticky bit. So that's pretty much it for users and groups and POSIX permissions from the command prompt. Um, I hope you enjoyed it, and I will see you later. Let's go ahead and test this now. We made some users, put them in groups, Austin Powers and Dr. Evil. We recurse out here. Print working directory when I go to home. So cd.what will recurse up one level. Do a long listing. And if you notice, let me blow this up here so you can see better. But you'll notice, in this case, every user that logs into the system needs a home directory, and it should be owned by that user and in that user's group. So what we want to do, let's make a directory for Dr. Evil, and for Austin Powers we'll make a directory, do a long listing. But as you can see, the problem is Austin Powers is not the owner of his directory nor his group, and the same with Dr. Evil. So let's remedy that. We'll use chown and chgroup, and Austin Powers should own Austin Powers, and Dr. Evil should own Dr. Evil. And let's change group. And Dr. Evil and okay, now I've got what we want. In this case, Austin Powers owns Austin Powers, and C Germany owns C Germany, and Dr. Evil owns Dr. Evil. So again, let's go out to the root, and we'll look at the permissions. Here's our top secret, and we set the sticky bit, but in this case, only the group membership good guys has permission to go in here. And let's tighten this permission up a little bit so that other doesn't have permission to read that directory. Now we've got, remember, the SUID, the SGID, and the sticky bit set here. So what we want to do is we want to remove all of the normal permissions for the other group. Do chmod, and we'll leave all the special permissions on, all the permissions for root in this instance, all the permissions for the group, and no permissions for other. And let's see how that changes things. If you look now, okay, the owner is C Germany, he's got full permission. The group is good guys. Good guys has full permission, but other has no permission. So if I log in as somebody who's not a member of good guys, I should not be allowed to go into this folder and do anything. That will be our test. Now let's check our groups again. Let's make sure that Dr. Evil is not a member of good guys. He's a member of bad guys. And let's check Austin Powers. And Austin Powers is a member of good guys. So I'm going to exit, and we're going to log out. And the first one we'll test is Dr. Evil. So let's log out here. And log in as Dr. Evil, whose password is a simple password. Now his desktop will be created in his respective folder. And let's go here, grab our terminal, and let me blow this up a little bit. Have to be careful using the expression blow up around Dr. Evil, but now he's in home Dr. Evil. Let's see if we can recurse out and print working directory. Okay. Now we can see top secret, and again, see Germany has all the permission plus the SUID is set. The good guys group right here has all permissions, 777, and in this case the SGID is set. But here, notice the lowercase t is capital T. The sticky bit is set, but other group has no permissions. Remember that was chmon to be 0. Now, Dr. Evil's not a member of Good Guys, so let's see if he can go into Top Secret. So we'll try to traverse that directory.